In the space of science and titanic mysteries, the subject of what existed ahead of time to the huge impact has sparked blended conversations and intrigued characters for quite a while. This enormous question doesn't just test how we could unwind the universe. It challenges the farthest limits of human knowledge. Imagine standing at the edge of existence, examining the colossal unknown and considering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of history, space, and everything we know. But was there a moment before it? Could something have existed prior? Could there have been a state of nothingness, a calm before the grand beginning? And if so, was it truly nothing? Or perhaps there was something even more unsettling that existed before time itself. As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, into ideas that challenge our understanding. Physicist Brian Cox, known for his contributions to the study of the universe, suggests that something astonishing might have existed before the Big Bang. He urges us to rethink our perception of reality and existence. In this discussion, we will break down the science, theories, and astonishing secrets that may help us understand what existed before everything. We will explore concepts such as cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may surprise you, but they could also open new perspectives on our place in the universe. Get ready to dive deep into a world beyond imagination and science, where the unknown still lingers in the shadows, leaving scientists both fascinated and, at times, perplexed. So let's explore what existed before the Big Bang. And why do these theories challenge everything we thought we knew? To understand what may have existed before the Big Bang, we must first examine what the Big Bang actually was. Scientists describe the Big Bang as the moment when the universe became incredibly hot and dense, rapidly expanding to give rise to all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot beginning, with galaxies spreading out from an initial point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or silent. Inflation theory suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, much like a vast vacuum. However, this vacuum was not entirely empty. It contained a massive amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it set the foundation for everything that followed. Within a fraction of a second, space expanded at unimaginable rates until the expansion slowed down and the energy transformed into matter, particles, and the fundamental forces we know today. But what was the nature of this energy? Why did it suddenly trigger the birth of the universe? And why did it stop? Scientists believe that this process of inflation created multiple regions of the universe, each experiencing its own Big Bang. Imagine a fabric stretching outward, with tiny bubbles forming throughout, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that there are possibly infinite Big Bangs and a limitless number of universes. Our universe is just one of many. This mind-bending possibility challenges our understanding of the universe itself and leaves us with an even bigger question. What else is out there? The idea of nothingness before the Big Bang is theoretical, but important for our understanding. Even if we remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and fundamental forces that weave an intricate tapestry of existence. Even in its emptiest form, space is not truly void. Imagine stripping away all these forces, leaving behind a dead space. The universe would still generate new forms of energy. This fact alone is baffling to scientists, as it suggests that true nothingness may be impossible within our understanding. Space itself has properties, laws, and constants that prevent it from being entirely empty. Even in a region with absolutely nothing, no particles, no radiation, no energy, quantum fields and fundamental constants would still exist. For example, zero-point energy represents the lowest energy state of quantum fields. In this state, particles can momentarily appear and disappear, creating an eerie echo of activity, even in what should be empty space. This challenges our traditional idea of a true void and suggests that, yes, even before the Big Bang something existed. Scientists are still unraveling this mystery. One of the most fascinating theories in modern cosmology is the concept of eternal inflation. If inflation created our universe, it is possible that it continues indefinitely. Brian Cox describes an unimaginably vast inflationary multiverse, where new universes are constantly being created and expanding. Imagine each Big Bang as a spark igniting another universe, while inflation occurs in different regions, creating countless other universes. This process could, in theory, continue forever. This idea of universes giving birth to other universes leads to the intriguing concept of a fractal universe, where each new universe may trigger its own Big Bang. Every universe would exist as a separate, independent space, unaffected by the others, due to the rapid expansion of space itself. For researchers, this theory is both exciting and unsettling, as it suggests an infinite multiverse with no true beginning or end. Imagine our universe as just a tiny fragment in a vast, boundless structure, constantly expanding and creating new universes. And what if the mind-bending truth is that there is no before or after, but rather an eternal cycle of universes forming and collapsing? Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe is not just a collection of matter floating in space. It is a complex network of energy fields that permeate the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy state, known as the vacuum state, they are still active. Particles can momentarily appear and vanish within these fields, borrowing energy before returning it. This phenomenon results in virtual particles, substances that briefly exist and then disappear, leaving only a faint trace of their presence. The concept of virtual particles challenges the possibility of a truly empty space. Imagine an empty universe where all matter, radiation, and energy are removed. Would you truly have nothing? According to quantum field theory, the answer is no. Even in a vacuum, fields remain active, occasionally creating transient particles. This constant activity in what should be nothing suggests that the universe never truly had an empty beginning. The idea of absolute nothingness may be an illusion, one that science is only beginning to unravel. See our concept of opportunity. The fields and powers endure, filling the universe with confidential energy that forestalls outright nothingness. This realization raises a fascinating question. If fields create particles and particles create matter, might the actual universe have arisen from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to certain perspectives, the fact that dark energy exists today suggests it may be a remnant of an energy field from before our universe's formation. The properties of dark energy seem to imply a colossal, hidden force that could have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, could have driven the inflationary phase, causing rapid expansion. The presence of dark energy suggests that even if our universe were devoid of all matter and radiation, this force would continue to shape the fabric of space-time. This idea leads to a profound question. If dark energy existed before the Big Bang, could it have played a role in the conditions that led to the birth of our universe? Could dark energy be the silent architect of cosmic inflation, or even the true beginning of our universe? As we explore this possibility, we confront the idea that dark energy is not just a force shaping our universe but also a key to unlocking the secrets of the multiverse itself. Another theory, cyclic cosmology, offers an alternative to the Big Bang as the ultimate beginning. It suggests that the universe undergoes vast cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of an eternal cycle where universes expand, collapse, and then regenerate in a new cycle. This hypothesis implies that our universe may have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, only an infinite series of universes emerging, evolving, and renewing themselves over and over again. Cyclic cosmology raises profound questions about time itself. It suggests that time may be cyclical rather than linear. If this theory is correct, it could imply that what existed before the Big Bang was simply another phase of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a compelling solution to the question of cosmic origins, suggesting that there is no definite starting point. The universe has always existed in some form, transcending our notions of time and existence. Gravitational waves are another intriguing concept that might provide insight into what existed before the Big Bang. These waves, first detected in 2015, are ripples in spacetime caused by the acceleration of massive objects, such as colliding black holes. Some researchers believe that these waves could have originated in the earliest moments of the universe, perhaps even before the Big Bang itself. If this is true, it could indicate that some kind of event or disturbance set the stage for the creation of our universe. The possibility of detecting gravitational waves from before the Big Bang raises the chance of uncovering traces from a time before time itself. As we venture into the unknown, we find ourselves at the very edge of what is comprehensible. The universe, with its vast web of possibilities, continues to stretch beyond our understanding. Was there something before the Big Bang? And if so, what could it have been? As we continue to push the boundaries of science, we approach a place where mysteries still reign supreme. What lies beyond our knowledge may forever remain elusive, or perhaps one day we will discover that before the Big Bang, the universe was just one phase in an eternal cycle, an endless march of creation and destruction, where time and space, like dark energy, persist forever. As we delve deeper into these profound questions, the lines between known science and speculative theory often blur. One of the most fascinating aspects of the universe's origins is the role of quantum fluctuations. In the quantum realm, tiny fluctuations in energy can lead to the spontaneous creation of particles that seemingly appear out of nowhere. These fluctuations suggest that the fabric of the universe might have emerged from a quantum vacuum, a state not of complete nothingness but one filled with potential, where energy is constantly shifting and fluctuating. This idea aligns with the concept that the universe may have been born from a quantum fluctuation, possibly driven by quantum fields that existed before the Big Bang. In this scenario, the Big Bang is not seen as a singular explosive event but as the beginning of a new phase in an ever-evolving quantum field. Some theories even propose that our observable universe is just one of many bubbles or regions within a vast cosmic multiverse. Each bubble could have different physical constants and laws of nature. In this view, the Big Bang may not have been unique to our universe but rather part of an ongoing process of bubble formation within a larger multiversal structure. These bubbles could have formed as quantum fluctuations in the primordial vacuum, with each universe having a different outcome based on slight variations in its initial conditions. Exploring this further, we encounter the idea that the multiverse may not be entirely beyond our reach. Some cosmologists believe that the possibility of detecting signs from other universes exists, albeit indirectly. For example, they propose that there may be faint traces of collisions or interactions between our universe and neighboring ones. These imprints could be found in the cosmic microwave background radiation or even in gravitational waves. Detecting such evidence would require advancements in our observational tools and technologies, but the idea of discovering signals from other universes challenges our perception of physical reality. Moreover, the concept of parallel universes opens up astonishing possibilities for understanding reality itself. If multiple universes exist, each with its own set of physical laws, then our very definition of reality could expand far beyond our current understanding. It might also provide answers to long-standing mysteries, such as the fine-tuning problem. This problem questions why the fundamental constants of nature are precisely set to allow the existence of life. If a multiverse exists with countless universes having different properties, it could simply be a matter of chance that our universe happens to be one that supports life. As we grapple with these mind-bending possibilities, the role of dark matter remains another enigma in understanding the true nature of the cosmos. Dark matter, which makes up a significant portion of the universe's mass, is invisible to our instruments yet exerts a gravitational influence on visible matter. Its origins and properties remain largely unknown, but it may be deeply connected to the fundamental forces that shaped the early universe. Some scientists speculate that dark matter could hold the key to understanding not only the moments following the Big Bang but also the very fabric of spacetime itself. Ultimately, as we push the frontiers of cosmological science, we are not just exploring the universe's past, we are also probing its future. The quest to understand the origins of the universe, whether through quantum fluctuations, cyclic patterns, or the mysteries of dark energy, may ultimately lead us to a deeper understanding of existence itself. This journey into the unknown is a testament to human curiosity and the endless drive to uncover the hidden truths of the universe.